Hello, it's Friday evening. Monday is a holiday. It is IM1, week 3. Your first day back will be Tuesday. And this is the lecture for Tuesday. So we have 3 objectives. The student will be able to recognize the function families. This is what we're going to be dealing with by their equations. Number 2, recognize the function families by their graphs. Okay. And your assignment is going to be number 3. Change a parent function and describe what changed. So 1 and 2 I'm going to talk about right now. Number 3 is what you will do on Tuesday. Number 1, linear functions. Well, the key to linear functions is the first 4 letters. They always create a line. The general formula for a linear function, right here, is f of x. This is how you say it. Since you're at home, I want you to practice saying these things. Okay, f of x equals ax plus b. A and b are numbers. You could say y equals ax plus b. This is identical when you graph it. So you can see it either way. Just know that they're both giving you a linear function. A parent function is the most basic form of the function. So the parent function for this situation is f of x equals x or y equals x. In this situation, the number in front of x is an invisible 1. There is no b, it's 0. So y equals 1x plus 0. That's what it could be. All right, that's the parent function. So when I say the most basic one, the parent function will look like this. This is y equals x. It's a straight line. It goes up and to the right. Here are some examples of linear functions. I don't want to read them all. I'll just cover a couple. You could say g of x equals negative 9x plus 17. Here's your a, negative 9. Here's your b, plus 17. Practice saying these. H of t equals 3/8 t minus 4. Here's your a, here's your b. Be able to recognize those. We're going to do a lot with them in about 4 weeks. And I'll pick one more. Y equals negative 11/6 x plus 3. Here's your a, here's your b, the plus 3. So what else could this look like? Well, you could have a discrete graph making a straight line that's decreasing. You could have an increasing one. So the graphs will be straight lines, increasing, decreasing. It could be this. Last one I'll give you is this, y equals 2. That would be this one, a straight line that's a constant function. This is the only one that has no x. So in this situation, it's y equals 2 plus 0x. The a is a 0. The b is 2. Next equation, quadratic function. Okay, quadratic. Quad, it means 4. Well, here's how I've figured it out. A 4-sided object is called a square. If it's a perfect 4-sided object. Well, all of these, I'm going to look at the the general functions, ax squared plus bx plus c. That's f of x equals. Or y equals ax squared plus bx plus c. The parent function, the most basic one, is f of x equals x squared. In this situation, you have an invisible 1, and you have a 0 for b and 0 for c. So here, b is 0 and c is 0 right here. These guys are 0. Or it could be plain old y equals x squared, which is the same graph as f of x equals x squared. In order for it to be a quadratic function, you must have a square on your variable. A square on your variable. That's a quadratic function. Put that in your notes. Here are some examples of what they sound or what they could look like as functions. G of x equals negative 9x squared plus 17. Here's your a. There is no x term, but there's a c. So in this one, b is 0. Here's more obvious. H of t equals negative 16 t squared plus 55t plus 4. Here's my a. Here's my b. Here's my c. The b has the t next to it. The a has a t squared. And I will do one more. Y equals negative 3x squared. Your b is 0 and your c is 0. One more. P of s equals 322 s squared minus 1065. Here's my a. Which one is missing? Here's my c. B is missing. What do these look like on a graph? Since they're quadratics, they will always look like this shape. A curve that goes up and down, or down and then up. The shape of this curve is called a parabola. Parabola. P-A-R-A-B-O-L-A. If you've ever been on the Golden Gate Bridge, that is a parabola. That's a quadratic function. You know what they look like? You know what the functions look like? This one will be very popular, powerful in IM2. You will do it quite a bit. Next one. Exponential function. Well, the exponential function. Key word is exponent. F of x equals a times b to the power of x. There's my exponent. X must be an exponent to be an exponential function. That's where the name comes from. All right, let's go to the parent function, the most basic one they've got. F of x equals 2 to the power of x. In this situation, f of x equals a is 1, b is 2 to the power of x. Just the 1 is usually invisible. Here are some examples. G of x equals negative 0.4 to the power of x. Your a is an invisible 1. Your b is your base. H of t equals 5 to the power of t. Here's your b. A is an invisible 1. I'm going to look at this one. Here's your a. Here's your b. It's easier to see. This one, very famous. I'm going to read it to you. R of t equals 2,000 times 1.07 to the power of t. You should practice saying this. This one is used with money. This formula is telling me if I save $2,000 at 7% interest, this is exactly how much money I will have in whatever number of years. I can predict 30 years, 100 years from now, how much money there will be. All of these functions look like, well, this. It could grow quicker, could be discrete. It could also be below the x-axis, and the formula could add more to it right here. In IM2 and IM3, you'll see more to it. We're not dealing with that. I just want you to play with this. And our last one, you see what it looks like on a graph. You see the examples of the functions. Our last one, linear absolute value function. Here again, we've got the word line. And this letter V is going to be key. The hardest part with this is learning how to say it. F of x equals a times the absolute value of x minus b, don't say this, plus c. So you have a pause. Y equals a times the absolute value of x minus b, pause, plus c. The parent function, most basic one, is f of x equals the absolute value of x. In this situation, The A is 1, the B is 0, the C is 0, because there's nothing happening inside the absolute value or after the absolute value. There's nothing there, 0. So let's try a couple. Same ahead of me. The top one, g of x equals negative 9 times the absolute value of x minus 8. Here's my A. Here's my C. There is no B. I'll just do one more or two more. F of x equals 1.25 times the absolute value of x minus 200. There is no C. C is missing. Is there one that has all of them? Actually, the middle one here. H of t equals 3/8 times the absolute value of t minus 4 plus 5. Here's my C. Here's my B. Here's my A. What do they look like as a graph? Remember I said the key is the word line and the letter V? Well, these all look like this. They all look like a V. Yep, they all look like a V. They can be wide. But the thing is, they should look identical on left and right. I should not see any of these V's looking like this. Nope, that is not good, okay? They can face up, they can face down. They can be discrete, they can be continuous. Is that all of them? That's all of them. So on your assignment, which we're going to talk about on Tuesday, you're going to have this. I will give you 4 links to 4 different parent functions. Here's the parent function right up here. And you're going to play with the parent function by moving these sliders. So you're going to do stuff like this and tell me what's happening when you change your A. I'm changing A right now. And what's happening when you change your B? So that's what you're going to do on Tuesday. That's all I got for you.